All right, hello everyone. For those of you joining us later, we are excited to have Riccardo Terrell talking about functional reactive programming and natural user interfaces with FSharp. But first, we are excited to have one of our community for FSharp heroes for 2015, Mr. Stefan Fortman. He is joining us today to answer the interview questions that we have been asking all of our heroes. So I want to go ahead and start out with him today. Stefan, thank you for joining us.
Hi.
So getting into these questions, and again, just as a reminder, those who aren't sure exactly what we're doing, these are to help us help the community know their heroes better. So the first one is, what was your first computer?
My first computer was a Commodore 64, and my dad bought it for his PhD, and I think I was 7 years old, and I played mostly games like Gianna Sisters. I think Gianna Sisters was the game that I liked the most, but then I started to program little games like Guess My Number and things like that. And actually, a couple of months ago, I was invited to Cambridge to talk about Paket, and the talk was in the Computer Science Museum, and they had all these very old computers over there, and it was a nice atmosphere, and I was, there was a Commodore 64, and they had all the games that were ever published, so this was really nice.
Well, that's really cool.
I could play the Gianna Sisters again. I liked that very much. I even found the cheat to go to the last level again. So.
Oh, cool. So where do you live now, and what do you do for a living?
Yeah, I live in Essen in Germany, and I work remote for a company called MSU Solutions, and the company is in Halle in Germany. I work for this company for over 10 years now, and we create software for energy and water companies. It's a billing system inside of Dynamics NAV, an ERP system, and my job is to create the billing engine. So it's the stuff where all the calculations are happening, and yeah, it's a really big calculation engine what I'm doing. So in a very old language called CRL. It's an ancient Pascal dialect, and you can't pass functions around or something like that, and you can't really create objects. So it's hard to do proper programming in that language, but somehow it works.
Nice. So it's interesting that you do that. How did you get into FSharp in the first place?
I think the first contact was in university for a project, and I was looking for a language that allowed me to express my problem easier, and so I started to evaluate languages, and I started with C#, but then I saw this prototype somewhere on the internet. So the very first version of FSharp was like, yes, this is exactly what I need, and so I started to go into this direction long time ago.
Very nice. And this next question is probably going to feel like a setup, but what is your favorite open source FSharp project and why?
Yeah, I have a couple of favorite open source projects, but the project where I work the most on currently is Paket. I hope to reduce this time from now on, but yeah, last couple of months was pretty much to do in this project, and I spent a lot of time in it. But yeah, I think we are nearly at the point where I wanted to be, so maybe in a couple of weeks I can relax a bit more about this project. So
I'm sure most people listening probably know what Packet is, but why is it your favorite? And can you describe it just a little bit in terms of what problems it solves?
Yeah, we started it from two different directions. One direction was that especially in the .NET open source world, people complained about NuGet and had problems with package management in NuGet, and especially the FSharp world had a lot of problems because I think the main problem was that NuGet is putting the version number of a package into the path, and so you can't use the FSharp Interactive to reference NuGet packages, at least not in an easy way, because you always have to manually update the version number in every script. This was one way, and the other was from our company standpoint. We don't really do .NET, but we have similar dependency problems, and we needed something that allows us to manage our dependencies in a better way. And this is my main motivation, to solve the problems that we have in our company. But it's not the same stuff that drove the .NET package version. So.
Okay, cool. What other languages do you use and or like?
So the language that I use most is this language called CRL, which is the ancient Pascal dialect. It's not that I really like this language, but it's the language that we have to use inside the ERP system. And so, so I have to use it, and after a while it's like Stockholm syndrome, so that you, I like it actually more than C#, to be honest, even if it's very old and you don't have all the possibilities, but it's also very hard to make mistakes in this language, so I think this is a plus.
Excellent. And last question, who in the FSharp community should people know more about?
Oh, that's a really hard question, really tough. But I think, I don't really know names about, but if we go to github.com and to the FS Projects group, then there's a people site, and it lists currently 86 people. So if someone is interested in learning new friends, I can recommend this site. So this is where the open source stuff is happening, and so yeah.
Fantastic. Anyone in particular you'd like to thank real briefly for help on projects you're working on or anything?
Oh, there's so many people. I will only, I don't know. I mean, we have over 100 people contributing to Packet, and
Wow.
over 200 people contributing to Fake. So I don't better start this. But I want to thank everybody. This is a really, really cool community, and so many people are involved, and everyone is driving in its own direction, but somehow people are working together and to make these projects and other FSharp open source projects great. So this is what I have to say.
Fantastic. Well, Stefan, thank you so much again for joining us today. Thank you for all your efforts and all your work in helping make the community better. And congratulations again, and thank you for being one of our FSharp heroes.
Thank you.
All right, and with that, we'll switch over to our presentation for today. Riccardo Terrell is, let's see, my screen shifted on me, unfortunately. Riccardo Terrell is a software engineer back-end at StatMuse Inc., who is passionate about functional programming. He is active in the FSharp community and started the DC FSharp users group. Riccardo is a believer in polyglot programming as a mechanism in finding the right tool for the job. He likes to describe himself as a functional guy living in an imperative world. Riccardo, thank you so much for joining us today, and I'm looking forward to see what you have to show. Just as a note to everyone, Riccardo does not have a working camera, so as he's describing the natural user interfaces, you'll have to use your imagination a bit to to imagine him touching things and moving his hands around.
Yes, indeed, indeed. All right, Ryan. Well, can you hear me?
Yes, sounds great. Thank you, sir.
All right. All right. So, well, thank you, Ryan. Thank you, everyone, for joining this meeting today. So let's see if I. Hopefully, you're going to see the slide in 1 second. Ryan, can you? Is it working? Can you see the slides?
I don't see the slides yet.
Yeah. Let's see. All right. I think that was it. Let me see. Still nothing?
Not yet.
All right. Well, let's retry.
Well, I can promise that the slides look good in the code looks good, because I saw them earlier when we were testing this out. So
Yeah, indeed. That's
go bear with us a few more minutes. I'm sure everything will start showing up correctly.
Yeah, I keep. All right. Sorry about this. Let's see what's going on here. I get the screen, share second screen. All right. I mean, I can see in my current my current computer that I see my slide, but you cannot see it, right?
Yeah, that's right. It's not showing up for some reason.
That's a bummer. Okay. Let's. Seems doesn't go through. Let me drop off and reconnect. Is okay?
Okay, that sounds good.
Right. Sorry about that.
I guess while we're waiting, we could ask Stefan more questions. I'm just kidding, Stefan. Thank you again for answering those. And I'm sure those who catch this later will really enjoy the interview. On another note, while we're waiting for Riccardo to join us again, next week we will have Isaac Abraham presenting on FSharp, Azure, and the web, the best of friends. So make sure to tune in for that one. That will be next Thursday. I believe that is, looks like 2 p.m. Eastern time. And I guess that would be I think that's 7 p.m. CET or 6 p.m. GMT. Seems we had a bit of a blip there. Here's Riccardo.
All right. Let's see if now this works. Sorry about that.
For what it's worth, the Hangout booted me off too, so I don't know what's going on.
Okay, I share my screen right now. And that's usually how it works, right? It was working just before the meetup, and now we are here struggling. So
yeah, I even see the little icon that looks like you are sharing your screen, but I'm not seeing it for some reason.
Yeah. Let's see if it works in the other way around. Yeah, it's weird because now it's telling me that I'm sharing, and in my local screen, I can see actually, in Google Hangout window, the browser, I can see that I'm sharing, right? But this is not.
There it is. Well, there it was.
And I'm doing nothing. I think it just
there. Okay, there's the code.
All right.
That's strange.
Okay.
Okay, oh. I think we're good to go now.
All hopefully.
Right. I see Visual Studio right now. I don't know if you were intending to show this or the slides.
Let the slides now.
Slides right there. Yep.
All right.
Okay.
Cool.
Excellent.
Well, thank you. All right. Thank you, Ryan, and thank you, everybody. Sorry about this inconvenience, but let's get started. So we have a lot of material to cover. I'm here today to talk about FRP as a functionality programming for natural user interface. So when I put this talk together, it was because I work actually in a project where I end up to introduce functionality programming in a project. So really is the result of a personal experience that I have. However, the first talk that I did in front of my wife, that she always, check my presentation, it was 2 hours and a half. So I cut it down and narrowed down to the more important topic and a material. So I will focus the majority on functionality programming. And as Ryan mentioned, it's hard to demonstrate natural user interface when you're streaming. However, I will touch a little bit of natural user interface in the end of the presentation with the last example. But all the high-level concepts we'll cover can be applied in any sort of user interfaces, including natural one. So the agenda for today, I will cover what is functionality programming, and I will spend a few minutes about introduce some concept about functionality programming, and hopefully resolve some confusion about reactive programming and FRP. I will discuss about the motivation and foundation of FRP, and also why it brought me to use FRP in my project. And then I will talk about how implement FRP with several code samples in Visual Studio using the original and the modern paper. And this terminology going to be will be clear later on when I will jump in the specific context. But I have several cool code examples in Visual Studio. So let's get started. Well, this is the boring slide, but Ryan already introduced me. But either one in the picture, and yes, there's my 2 fellas loving pug that I'm here right now. Listen to me. And yeah, as Ryan mentioned, I currently switch job, work for StatMuse as a startup in San Francisco where we provide natural language interfaces for sport analytics. All right, so let's start with functionality programming. And so what is FRP, right? So this is not really an easy answer because there are 2 different spectrums here that we have to consider. One is the academic side, the academic industry, where define FRP as that is a paradigm all about values that change over time. But from the other side of the industry, really functionality programming is more like, to me, a set of different terms that can refer and have different definition, right? So there are some confusion about some terminology that have something in common. There are some commonalities, right? And to me, in my opinion, is that if you think about these three words, functional, reactive programming, but if you try to combine these three words in a different manner, you also have different meaning. First of all, we have, of course, functional programming, and probably I want to give any kind of definition with the audience of today, but we define functional programming as a paradigm, right, that treat the computation as the evaluation expression and avoid mutation and the change of state, and also emphasize composition, which is probably to me the more important tenets of functional programming. And but then you can brute force or recombine these three words together, and oh yeah, and of course you have different kind of important property in functional programming. But so if you play again with the words here, we have reactive programming, and really reactive mean responsive to stimulus. No. And reactive programming really become ubiquitous. If you're building any kind of application where there is a real-time component, then most likely will be exposed to reactive techniques. And there has been a lot of confusion about reactive programming because people think that if you can do high-order operation event such as map, reduce, flat map, and so on, you're doing functional reactive programming, but this is not true. However, there is a close relation between reactive programming and functional programming. Because reactive programming use functional construct to obtain composable event abstraction, right? But this is not functional reactive programming. Like for instance, here in the slide, you have a simple FSharp code where you can see we use event combinators to apply high order function to some sort of streaming event coming from Twitter, right? So we can apply filter, map, and so on. And this is reactive programming, but this is not functional reactive programming. The classic example of reactive programming, I think is the canonical example, is the spreadsheet, where we have a cell C that is bind to a formula to two values being in a cell A and B. By changing any value in A and B automatically, and the value in C is updated, right? So this is probably the most used reactive programming in Excel. And then finally, we have the three words together, right, which is the topic of today, which is functional reactive programming, which are talking about originally a paper that was written by Connor Elliott and Paul Hudakit almost 20 years ago. And functional reactive programming is all about be able to compose dynamically evolving value over time, which means you can get values that vary over time, but still avoiding the mutational state. And the idea really of functional reactive programming is that integrate time flow and also event compositional event aspect by forcing, still the functional programming rules. So think about really functional reactive programming as a subset, some sort of a paradigm that stick in between reactive programming and functional programming. So this is the original paper in the 97, which describe functional reactive programming using Haskell by writing a library called FRAN as functional reactive animation, which originally was designed to interact with the graphic, two-dimensional and three-dimensional graphics. And FRAN is based on the notion of polymorphic data types, behaviors and events, which cover the value of the value that continue to change over time and continuously or discretely. So in these two concepts about behavior and events are still used today in modern functional reactive programming implementation and will be discussed deeply later in the coming slides. But this is our some example where functional reactive programming provide a way to express, computation is such as in domains that are related to animation, right? We have robotics and implementation of graphic user interfaces and so on. And really the idea is that avoid and reduce the complexity compared to a traditional paradigm. And ultimately, lately, FRP is being used in virtual reality in games, and of course, natural user interfaces. And FRP really evolve over time, right? It's become mainstream, and it changed also the implementation and in different direction. Here in the slide, we have different frameworks and library that use FRP concept. You can see how there is a close relation between front-end development and FRP, and really because this paradigm really influenced, this kind of development style. And what is interesting in this slide is Elm, which is the square with the green, yellow colors. And because I'm not an expert in Elm, but and really I play with, it seems that Elm, the approach is a bit different. Really, it's not just a framework, but really try to rewrite almost a new language with the intention to make, the goal to make functional programming more digestible to programmers. So that's a bit, the summary of where FRP come from, and we are still using it today. Probably we don't know we're using FRP, but there are several libraries that are using it. But so what is FRP? Well, it's a paradigm for building erratic system, and as I mentioned, provide composable abstraction for dynamics values. And this value is a very precise denotational semantic, which is a mathematical model that I will cover, I think, in the next slide or two. But it's been used in FRP, denotational semantic, to build an elegant vocabulary around your libraries and API. And I definitely recommend it to use the same approach when you build your own API. And we'll see why in the coming slide or two. So there are two main ideas, let's say, idea that shape functionality programming. One is denotative, which means that you use, as I mentioned, a precise compositional semantic to specify the meaning of each type and building block. And then we have the second concept called temporally continuous, which is, I mentioned, really focus on a composition aspect of functionality programming and how we can use composition correctly to prove that we can use composition correctly in this building block. So the notational semantic is, as I mentioned, is a simple concept, right? Is a mathematical expression that represent the formal meaning of your program or programming language, right? Like in this slide, we have a simple function in Haskell, which is a programming language we are very strong in the notational semantic. And the notational semantic is when, for example, in a programming construct is given its mathematical interpretation, right? With that, you can have a property in your program or a function, and to prove the correctness, you can use mathematics, right? You can use maybe a mathematical theorem, sort of. And what is interesting is that the notational semantic, the idea, the goal is that it tends to express the meaning of the program by showing not what happened if you run or execute the program, but instead they focus more or translate or giving more a different kind of representation, mathematical representation from the native language that you're using. So in this slide here, we have this function, this Haskell function, which is pretty clear what it does. Like, is a factorial function. We have an expression, which is the number that go from 1 to n, is a list of integer, and then we have a function product that multiplies all elements in the list, right? And this is just like really represent a definition with that come from a mathematical textbook, right? Now compare the same implementation using C, like, so I think it's pretty clear what the difference between a language that use the notational semantics versus a language that doesn't, right? And one interesting aspect about the notational semantic that's really shine in functionality programming is the compositional aspect, right? And that really we can use the notation, the notative part to construct your program, right? As here an example, we have we can compose the factorial function with expression 1 to n with the function product. And the benefit really is that it fit quite well in FRP, the notational semantic. And Connor Elliott, which is the father of FRP, in his paper has a very strong opinion regarding the notational semantic. As I mentioned, really provide this mechanism for building a vocabulary around your API, an elegant vocabulary, and with the goal, the intention to provide a very simple design, right? And simple design, as described, the goal of the notational semantic, simple design lead to an easier way to reason about your program, right? It gives you the opportunity to reason further and more deeply. And when you're building your API, well, it's easier to have a more elaborate and complete library, right? So really the goal are the notational semantic is a reusable abstraction, but really an elegant semantic. And that's finally bring us to the how we can describe FRP, right? So how we can implement this model, this paradigm. So first of all, we have this notion of time, right? Continuous time. And so the domain time is synonymous of real number. And in FSharp, we are using the float. They chose, in FRP, there is this notion of continuous time, which for me was strong to grasp in the beginning, but really the idea provide more composable and modular programming model, right? Compare with a paradigm they use a discrete time. And modularity really is about modeling, as Cornelio said, and FRP, in FRP modeling is achieved through this concept of continuous time. And we're using here record type in F# because when you keep changing and of the time, continuous time, we can just use the with keyword. I thought to use the unit of measure, which is in my to-do list, which I think should be an interesting approach, more intuitive. But so let's bring us to something else, right? Well, let's step back. We define continuous time, discrete time, and also there is this notion called virtual time, right? And virtual time is used in modern library, such as reactive extension. So continuous time, I think, is pretty clear, right? Think about your clock. You take a look now, and you take a value, right? You wait and take a look later, you take a different value, really because the time continuously change, right? And really, the time is always going flow behind the scene. Discrete time, this is like, think about the click of the mouse, right? This is discrete because it happens when not continuously, but with the interaction of the user, for instance. But then we have virtual time, and this is the notion of virtual time is the notion that allows you to switch the concurrency model at any time at the computation, and so we can perform the same kind of high order operation that we did regardless the time aspect, right? For instance, a virtual time allowed us to rerun through historical data, right? And the value could have a timestamp of 10 years ago, but we don't care, right? We can rerun it right now. Behavior. So this is probably the central type in functional reactive programming, which sometimes is called signal in modern implementation like Elm, and is represent
Riccardo, are you still there?
Okay. Can you hear me? Hello, Ryan, can you hear me? Can you hear me? I think I'm back. Ryan? Let's see if Ryan can. I think that I lost you when I was in this slide here, and hopefully Ryan can confirm. Oh, it seems that Ryan lost the communication, but okay. I think at the end we have just bad connection, everybody here. All right, so okay, I just keep going, and then probably I was talking about behavior, right, as a central type in functional reactive programming. And semantically, behavior is a function from time to value, which means um, that you can sample the behavior at any given time and yield a value, right? Think about the mouse, right? When you click, that's conceptually discrete, but the motion of the mouse is continuous, right? That can be represented with a behavior. And we are using in FSharp a single discriminator union because we'll see later in the code sample, we can use pattern matching to extract the current value in the function. And with that, we can already simplify, we can add some simple types. Here we have the behavior time that return time itself, which is the identity function. We have the constant behavior, just always return hello FRP. And the last one here is about transforming a value, right? It's always, we can, in this function, increase speed, represent the speed of behavior that really is a function that increases speed over time, which is quite nice. And this is the API that comes from the original paper. As you can see, we have, the classic implementation, such as, the lift function, where we can use the value, we can lift the value into the behavior box, behavior word, or whatever you want to call it. And then we have the lift one, lift two, and also the map function. And with this simple API, however, we can, rewrite some of some function here, right? We have the time, but we have the square function, which is interesting. We use the map function, and what it does, the square, it really is the behavior square really gets the result not right away. It's not executed until we ask for the actual value and at the specific time. So we ask for the value for the specific time, right? And we can do this and execute the function that return as a result from the map function. All right, so I think I have two more slides and we're going to jump in a code sample. But the last interesting type in FRP is the event, right? Because behavior are continuous, right? But sometimes we should react, right? And to discrete event, which can change or create a new behavior, can update the value of behavior, right? And we can, and for that, we can use event, which is polymorphic data type, which can have a value or not, and it is discrete. And in the slide here, you can see is an event represented as a sequence of time order pairs of time value. and where the time is monotonically, right, because it is continuous, right? And for each value, we have a timestamp that indicate when the event occur in the specific time. So for instance, here we have a function that is executed after maybe 3 seconds and return, a speed increase of 2.5. So this is an example, and bear with me. It's not very exciting, but later we'll see how we can write this example in a more modern fashion. And so first of all, I want to mention we have the mouse move event, right? So the idea of this function is a two-state behavior that check if the mouse position is inside a rectangle. So with the traditional paradigm, we can get the position of the mouse with a mouse move event. However, this is more like this is not true FRP, because the mouse moves event, you use the event as a discrete representation, but instead it should be continuous, right? So that's why the FRP view of the mouse position, you use a behavior. And here in the rectangle is a behavior that you pass two arguments, the upper left and lower right coordinated of the rectangle, and return true or false accordingly if the mouse is inside the rectangle. Now, you can see here inside the behavior in rectangle, we sample the mouse position. We use the parentheses there to get the value of the rectangle, and then return true or false accordingly. But what is interesting, that really is really fascinating for me, is the fact that now we can associate a value to given time, right? So the idea really that behavior is as a function of time instead of the ordinary values, right? And the dot here in the slide represent, discrete events. All right, so the last slide, but and then we're going to jump in a code sample. So this is all great, right? But how we can implement one yourself, right? This is a code, a link to a Stack Overflow where Cornelio answered a question, and in the answer he said that functionality programming overall is based upon simple concept that you should be able to invent it yourself. So, and I struggle actually my first implementation, because FRP to me is a very fascinating topic, right? We have, as I mentioned, behavior, and this concept about function of values over time. We have these beautiful semantic, and it all plays nicely together, right? We can use equational reasoning to transform your program and the notational semantic, but this is all hard to put all together. However, this is what Connor Elliott answered. It really summarized what we saw so far, right? So this is really the main, the sense of functionality programming, these 4 points. One is temporal modeling, which based on behavior that a first class value and can be composed and created by other value, right? Like the in rectangle behavior example. Then we have the event modeling, which cover the discrete side and the event that are first class values. The creative reactivity, and we discuss probably later, but really express how we can express behavior in terms of reaction to event, because overall behavior have some point to change value or change over time, right? And we have to create behavior based upon other behavior, and we use event. And the polymorphic media just, is a set of polymorphic combinators that are used to combine event and behaviors. All right, so it's time for a demo. So hopefully you see the Visual Studio code here. So we have I have a few examples here. The first one, the bank account, it probably is not very sexy, but I'm going to do quick and moving forward for something more in line with the functionality programming. But it's just the idea that functionality programming is based on values that change over time. That doesn't need necessarily associated with graphic design or user interfaces or anything related to front end. But even think about a stock, right? A stock price. Even the stock change over time, right? So you can apply this kind of paradigm in different programming model. So here we have our primitive type here, the time, the behavior, and the event as we described in a slide. And this is, as you can imagine, is a simple bank account, right? We have the deposit and the withdraw event that are just, I use the new default API, and I'm gonna probably show later quick how the library is implemented. But really create an event with the default value. In this case, the deposit and the withdraw will be 0. The account event, well, I can use the merge function. You can see probably here the signature. Well, let's see actually if we can go. So the merge function, it takes 2 events of the same type and return a new event, right? So now we are merging the deposit and withdraw event together. So every time I make a deposit or the withdraw, this event fire up and do something. So what it does? Well, in line 22, when I define my bank account behavior, I can use the event and I use the accumulator function. The accumulator function is one of the more interesting to me. And what it does is take initial value, mapping function, and an event. But really, the accumulator take initial state, an event, and really start to produce new event when the event fire and update the current value of the behavior, right? So really is a producer of a stream of value. And I just expose my my value through some property here. The balance, I get the current value of my bank account. You can see use the sample because you have to sample the behavior to get the current value. And then we have the deposit and withdraw that I just pass an amount, send the function, send the value to the event which trigger, right? So this is a pretty simple program here, but you can already start to see, and we'll see later with a graphic example, how simple combinator like merge and accumulator we can use to combine an event behavior to describe our programs. And the positive is that we don't have listener, we don't have callbacks, and we don't have mutational state, right? It's all hidden by the API. Right, here is the program, right? Just I created the bank account with initial value 10, and then I start to send a deposit or get some money from the bank account, which underneath I'm gonna fire up my account event, my account event, and update the current balance. So if I run this program here, I'm expecting a series of printing a console different value. And you can see here start with 10 and keep updating, sampling the balance and printing a console. So this was a simple example, right? Let's see something a little bit more in line with the functionality programming. Okay, so of course, functionality programming is about, the majority about front-end development and graphic programming. So think about how we can program here a user interface, right? So let's see. Okay. So I have a sort API here that are in a project that, by the way, are all in GitHub. So you, in the end, I provide the link. You can download the slide and the code sample. But in this library here is the first implementation that I did for functionality programming, and I cheat a little bit here because the project had to interop with C#. So I have to expose the API in a imperative friendly manner, right? So the behavior here is represented as a class. So C# could instantiate a new behavior using a construct. And we have a series of functions here that are part of the behavior object. So the implementation still follow the functional paradigm rules with immutability, referential transparency, and so on. But unfortunately, the function belongs to the instance and object. However, what is nice is that with FSharp, I can extract the function in external module and make it more functional friendly, right? So I still use underneath it the library that I built, but I expose the function that did not belong to my type, right? Which is probably the right approach. All right, so oh, I probably okay. So let's start with a simple graphic example, right? So let's see, what is it? Okay. So the first implementation, you see, I just draw a circle, purple circle in my WinForm app, right? What I do here, I just create simple API in the back that we can check here. Is a record type, which just simplify my programming model. I just a behavior that represents my drawing and some other information here. In the top here, I have my series of simple helper class, helper function, like to design a circle, a rectangle, and so on. And we have also the merge and compose, with just merge some images. All right. So I have this problem here. I don't know what's going on here, but let's run to the next example here. Okay, sorry about that. I have to figure out what's going on with that part. Okay. Okay, so now let's try to figure out how we can merge, right, or compose images, right? In this case, I create two circles, right, one orange and one purple, and I put it together with the merge function that we already, so in this case, I merge two drawing images. In this case, if I run this example, right, we have one circle because both are the same radius, right? But if I change the radius, in this case, I'll probably be able to see both circle. Okay, now so now I create this, but I don't know why I still getting the same problem here. About that, I have a problem here. Circular animation. I know what's happening here. Let's bear with me 1 second. I need to figure out what's going on. But there is a problem here, a bug that doesn't go away. And I might see what's going on. Okay, so the idea that I want to show right now is when I figure out why this is not working, is how we can compose by, okay, how we can compose images, right? So let's reset. Okay, now it should be. Okay. Now we were here where we designed two circle, right? Now, if I want to combine animation, right, we can create a circular animation just passing seno coseno. We just create a range between a value that I pass in my function, right? In this case, below here, I create values of 125. So with that function, I create a range from negative 125 to positive 125. So, and you can see how these functions are behavior, right? Because I lift the function in the behavior word. Now, the rotate function, I take this function that mutate and map the behavior, which is represented here in this line, right? So the rotate one function, I just pass the same coordinate x, but I change the y, and I do the opposite for the rotate too. So my intention is create animation that you have two circles that spin together, right? Okay. I don't know why this is not friendly today, and that okay. Oh, okay. That's not what I'm expecting here. Sorry about that. Something happened today, and this is not helping. Oh boy. Okay. Hold on 1 second that I fix the problem here. Okay. In meantime, I see why this is not working. Okay.
This was one of the ones that was working earlier before
Yeah,
we were
I
testing
know.
out, right?
Yeah, I don't know what's happened, and I try to figure out. Bear with me 1 second. Let's see if I have. They stop working all the operation value, which means something got go wrong with the operation. Oh, I know probably why. Well, in the meantime, do you have any question here? Like,
There are no questions in the Q&A. By the way, for those of you who are watching, if you do have questions, there is a small box of boxes, I guess I keep calling that icon, on the top of your screen, or you should see one, that you can use to switch from the showcase with the links to the Q&A section, and you can ask questions there if you would like. You can also ask questions on Twitter. I've been following the feed there. I haven't seen any questions pop up there either, so.
okay. Do you, Ryan, have any question?
Not so far.
Okay.
I've been able to follow it pretty well so far. So.
All right. I saw you got, okay.
Yeah, I got booted off earlier as well, but
Okay.
yeah,
right,
it makes a lot of sense so far. So thank you for pushing on with this.
Yeah. Okay, I think I got it. All right. I think I just. Okay. See if it works now. Sorry about that again. We have some problem with connectivity now. My code was working, and now, of course, it started to be friendly with me. Okay, I think we're back here. All right, I'm gonna skip one example here. So, but let's go to something a bit more interesting. I think this is. So, as I mentioned about combining behavior, right? So I'm gonna just run everything here in the repo. Okay. So we designed one circle and has kept the second example about two circles. But what about if we want to, combine different circles together? Here we can create different circle, right? This function here that create, some coordinates, some brush, and create a behavior that just drawn a circle. And I create 5 circle, right? And here I use the rotate function that applies some animation to my um, image that I pass here in a function, right? And the idea is that the distance that I pass is constant because when they rotate, of course, the radius it will be always the same, won't change. And I can merge all the images together using this infix operator, which is just the merge function to merge different behaviors. All right, so here I have my pretty flowers, right? So I've composed all this behavior together, and also I can run animation, and the image can spin. You can see here the main idea is the switch operator, right? The switch operator take a behavior and a function, an event,